Okay, guys, so what I want to do now is we've learned about the log properties. So now what I want to do is start solving some log equations. When we did the exponential growth and decay and the interest formulas, we already did we used log in some ways. So what I want to do is walk through some examples of showing you how to use logs to solve equations. So this would be a good time for you to get just a blank piece of paper. I'm going to do an example and then I'll have a second one. You can pause the video and try that second example on your own, then unpause it and check your work to see if you did it right. So when we did exponential growth and decay, we often solved problems that ended up looking like this. So I have some number raised to a power of x. So we talked about the fact that when your variable is in the exponent, this is when we know that we have to use logs to solve. So by taking the log of each side, it lets you move the x out to the front. So you have x times log of 2 equals log of 3. So now to get x by itself, the only thing that we have to do is divide each side by log of 2. So now in your calculator, all you have to do is type in log of 3 divided by log of 2. So we get about 1.58. Okay, so for a different example, very similar, just one extra step in it. I have 8 plus 10 to the power of x equals, let's go with 1215. So you can try this one on your own if you want. Before you start it, one of the things that you need to be aware of is you have to get this by itself first. So we have to move the 8. So you could go ahead and subtract 8 from each side. So again, if you want to, this would be a good time to pause this and try this problem on your own. Okay, so now to get the variable out of the exponent, I'm going to take the log of each side so I can move that out to the front. So I have x times log of 10 equals log of 1,207. I'm going to divide each side by log of 10. And I get x equals approximately 3.08. So these are problems that we are at least a little bit familiar with. We solved problems like these when we were doing, like I said, the exponential growth and decay and the interest formulas. So I'll do one more of these just to show you something a little bit different. We saw this more with the interest formulas. So if I have 9 to the power of 2x equals 66. Again, if you want to try to pause it, this would be a good time to do that so you can try it and see if you remember how to do this. So our interest formulas oftentimes had something extra up here with the x, because remember in that continuously compound interest formula, it was PE to the power of RT, so we had two things being multiplied. So you're still going to do this much the same. You're going to take the log of both sides, so that you can move this 2x. So this is 2x times log of 9 equals log of 66. Now we want to work to try to get the x by itself. So the first thing I'm going to do is divide both sides by log of 9. So in my calculator, log of 66 divided by log of 9. And I get something like this. Remember, we want to try to avoid rounding. So with that still in my calculator, I'm going to hit now divide by 2. So x equals approximately 0.95. So like I said, we've seen problems like this before. This should be nothing new. So what I want to show you now are some problems where log is already in your equation. So we have log of 5x equals 1. Okay, so what we want to do is we want to try to solve this problem. And this can be a little bit tricky. So one of the problem or properties that we learned in a previous video, I said that logs are your bay, and that stands for base answer exponent. So when your problem is in logarithmic form, you are allowed to use this acronym. Now, another thing that we've talked about is the fact that when you have a log, if there is no number here for the base, we assume that it is 10, okay? So I want to go ahead and fill that in and just kind of get yourself into a habit of filling that in. So now what that means, that's my base. The next thing is my answer, and this is my exponent. So using this, I'm going to rewrite this into exponential form. So it is a base of 10, an exponent of 1 equals an answer of 5x. So we're switching back and forth between logarithmic form and exponential form. Now this is going to be pretty simple. 10 to the power of 1 is just 10. So I have 10 equals 5x. So to get x by itself, all I have to do is divide by 5. So I get x is equal to 2. Okay. So let's look at a different one. So let's do log of 3x plus 1 equals 2. So the first thing I'm going to do is fill in my base, and then I'm going to use my BAY acronym. So I'm going to write this out, or I'm going to label this as base answer, this whole thing, and exponent. So now I have a base of 10, an exponent of 2 equals an answer of 3x plus 1. So by rewriting it in this way, you are just creating a pretty simple equation that you can solve. So 10 squared is 100 equals 3x plus 1. So now to solve, I'm going to subtract 1 on each side. So I have 99 equals 3x. Divide both sides by 3. So x is equal to 33. Okay, so next one, this would be a good time for you to pause and try this on your own. So let's do log of x plus 1 equals 7. Okay, so go ahead and pause it and try it on your own. Okay, so I'm going to fill in the base of 10. This is my answer. This is my exponent. So now I have base of 10, exponent of 7 equals an answer of x plus 1. Now, 10 to the power of 7 is a big number. So that's okay. So don't be panicked if you get a really big number. So this is 10 million equals x plus 1. So the only thing I have to do now is to subtract 1. So if you subtract 1 from 10 million, you get 9,999,999. Okay, so don't worry if you get some crazy weird numbers. When we did the exponential growth and decay, a lot of times we ended up with weird decimal numbers. So if you end up now with really huge, crazy numbers, don't worry, that's pretty normal. Okay, one more example of this type. So let's say that we have 3 log of 2x equals 12. So one of the things that we have to do is we have to, before we can use BAY, is get our log by itself. So that means in this particular problem, I have to get rid of the 3. So I'm going to divide each side by 3. So I will have log of 2x equals 4. Now this problem looks very, very similar to the ones that we've solved previously. So now I'm going to fill in my base of 10. base answer exponent. So I'm going to rewrite this as 10 to the fourth equals 2x. So 10 to the fourth is 10,000. So 10,000 equals 2x. Divide both sides by 2. So I end up with a final answer of x equals 5,000.